Hi everybody, in this video series we're going to take a look at oxidation-reduction reactions. Electrochemistry is the study of the interchange of chemical and electrical energy. All electrochemical reactions involve the transfer of electrons from one reacting species to another. These types of reactions are commonly referred to as oxidation-reduction reactions or redox reactions for short. These include synthesis reactions, single replacement reactions, and combustion reactions. So you're familiar with a lot of these reaction types already. We're going to take a look at them from a new perspective by keeping track of how the electrons are transferred in these types of reactions. Not all reactions involve the transfer of electrons. These are called metathesis reactions, and they include double replacement reactions, and some synthesis and decomposition reactions also fall into this category. In order to determine whether a reaction has involved the transfer of electrons, we need to keep track of each atom's oxidation number or oxidation state. The oxidation number is just the real or apparent charge of an atom or ion if all the bonds in the chemical species were considered to be ionic. Now it sounds a little bit complicated, it's not. So let's look at some of these rules here. So if I have an atom in its elemental form, its oxidation number will be 0 because it doesn't have a charge. If I have a monoatomic ion, then the oxidation number is just that ion's charge. Oxygen, for the most part, is going to have an oxidation number of -2. The exception would be in peroxides, for example, hydrogen peroxide, or in the situation where I have oxygen difluoride, where the oxygen will actually have a +2 charge. So for the most part, it's going to be -2, a couple of exceptions there. Hydrogen will have an oxidation number of +1 in most situations, except in metal hydrides. So for example, lithium hydride, it will actually have a charge of -1. If I have a compound, the oxidation number in the compound must sum to 0. That's a lot like making salts. Okay, the overall charge on these types of compounds is 0. If I have a polyatomic ion, then the oxidation numbers have to add to the ion charge. Rule number 7 says always assign the more electronegative element a negative oxidation number. So sometimes we have a compound with multiple non-metal elements and we don't know what to put for their oxidation numbers. We're going to choose the more electronegative element to have the negative oxidation number. So for example, in phosphorus pentafluoride, fluorine is more electronegative. Fluorine is the most electronegative element on the periodic table. So therefore the fluorine will have a charge of -1 and the phosphorus will have a charge of +5. The last rule, in a compound or ion containing more than 2 elements, the element written furthest to the right takes its most common oxidation number. So again, this last one is in some trickier situations. General rule here is if you're not sure what oxidation number to put the most common oxidation number for the element furthest right.